Like I said, I had been invited by Dr. Brigida Wallace of Parks Canada to work with her and a fellow from Norway called Arne Espeland, who's a historic metallurgist, and assisted by Mark Pilgrim, who was one of the staff interpreters there that I trained. And we tried to make iron. And the furnace we built, a little bit bigger than the lectern here, lectern, so, you know, the length of your forearm in 4 directions, and maybe about 30 centimeters tall. And we threw all the ore in a big blob on the top, and we set it on fire, and we thought we'd get something. And what we got was nothing. All right, because surprise, surprise, not one part of that chain would ever have been successful. But at the time, although archaeologists have been studying this in Northern Europe, I shouldn't say no one, very few people had actually physically ever tried to do it. The doer and the thinker, and this is going to come up again. We were firing with charcoal, we were using local bog ore right off the same ground that the Scandinavians had gathered theirs, and the air was provided out of a small twin-chambered alternating pump bellows, which is again going to come up. Moving into 2003, I had the opportunity to meet 2 guys from down in the States, Skip Williams and Lee Sauter. And Lee is the grand old man of successful iron smelting here in North America. And they had originally been interested in African technologies, and they had developed something that worked. Didn't look anything like the archaeology, but they could get it to work. And Lee was blessed by having a type of limonite, quite pure ore. Remember I was talking about that ancient stuff that got laid down a billion years ago? Put mud on that, a lot of mud, and compress it. And then wait a million years and let the sea drain away, and then the land lift up, and you get the Blue Ridge Mountains. Okay, now imagine a peanut butter sandwich. Okay, the bread is limestone, it's the compressed mud. The peanut butter is a layer about 20 or 30 feet thick, runs under the entire Blue Ridge from bottom to one end to the other. So in colonial times, what they would do is they would go to the edges of the mountain and find the layer and dig into it. Typically, they would take some people they didn't like a whole lot, and they would get them to dig in there until it collapsed on them. Then they'd move over 150 feet, you got another bunch of people they didn't care about too much, get them to do it again. So the fact that we had learned a system that would work, I started then taking what Lee and Skip had taught me and trying to apply that to a more historical model, a Viking Age model. And what we developed is what now has been come to call the short shaft furnace. And that image you can see there would have been 2003. And you can see the furnace is about the diameter inside of a 5-gallon pail, plastic pail, and about 2 of them stacked on top. Okay, and it took us a while, but we eventually figured out how to do this quite effectively. That smelt, by the way, we got nothing. Lots of slag, but nothing else. Part of the problem was I found that there was a real isolation between the academics and the practical workers, and they didn't talk to each other at all. And so much that was available in the academic literature was plain wrong. That method that you see described there will not work. It also doesn't properly illustrate what the inside of the furnace looks like. Our problem is in the archaeology, and I was talking to some people at the start, our clay furnace, it's clay. Hit it with a couple of thunderstorms and it's gone. What you get, and the iron, we take the iron away because it's valuable. We were hard to get it. What we find is a ring of slag with maybe a bowl shape in the middle of it. And after 1,000 years, that's all we find. How tall was that? Where does the air go in? How fast do you add the stuff on the top? How big are the pieces you put in the top? All those questions were not answered. So what happened is one of the other crazies here in North America, and this would have been 2004 to 2005, started an association of people that were crazy enough to be interested in this called the Early Iron Symposiums. This is Michael McCarthy out of the Farmers Museum in Cooperstown, New York. And the first year he gathered about 90 people from across mainly the United States. And we tried it. And we had spotty results. We didn't get our first actual iron bloom until smelt number 6. And if I haven't mentioned this to you folks, because I was telling Tim upstairs, every time we do an iron smelt, it costs about $350. So we had done this 6 times at that and hadn't gotten anything. So Lee gathered together some senior members of people who were serious about this research, and he would invite us down for 10 to 14 days at his place down in Lexington, Virginia, and we would make iron for a week. And we'd typically break into 2 teams. One team would build, the second team would fire, and then we'd alternate. And we would change one thing. What's the angle? What's the position? What's the size? What's the particle size? So we were able to put together a whole series of ideal working conditions to get this to go. In that period, I developed what I call the Okano-Norse furnace. It's basically a pile of fire brick with a piece of sheet metal around the outside of it, and you put sand between the bricks and the sheet metal to stabilize it. And you can build one of these in probably about 15 minutes, and it's a bunch of fire brick. It's not expensive. And then when you go to get your bloom out, what you do is you just take the sheet metal off the outside and just pull the bricks off and expose the bloom. Makes it really, really easy to do. As we established, you can see what I'm doing as I'm going through the chronology of how I developed this over the last 20 years. 2005, we basically got a basic method, and quite arrogantly, I approached the people who were running the Canadian National Blacksmiths Conference that year out in Nova Scotia, and I said, we could demo Viking Age iron smelting at your conference. Yeah, which in fact we did. We didn't necessarily have the best results, but it was the first time that our work then had been presented to the general public. So here's some of the variables about how to actually get this to work in your backyard. There's a relationship between the size of the type of ore you have, how big the pieces are, and how big the charcoal is. The process we were talking about of carbon monoxide to dioxide to reduce is a gas chemistry. It doesn't work in a solid. So you need to have either real small pieces of ore or ore that's porous. When you get a chance to look at the natural bog ore, you see it weighs almost nothing because it's all full of holes. But if you're working with a rock ore, you've got to get the size right. Charcoal, if your charcoal's too big, the spaces between the pieces of charcoal are too large, and your ore falls too fast, it doesn't get a chance to react. If your pieces are too small, what happens is it clogs up the airflow through your furnace, and the fire isn't hot enough. So there's an ideal size, which happens to be, surprise, surprise, about the size of a golf ball. And nothing smaller than the tip of your little finger. So 5 millimeters to 25 millimeters. Surprise, surprise, if your ore doesn't have at least 50% elemental iron in it, you won't get anything out of one of these old-style furnaces. Modern furnaces, anyone here ever seen a taconite pellet? It used to fall off all the railway cars coming down from Northern Ontario. So it looks like a red marble about a centimeter across, half an inch across. At the mine, they can take ores 35% iron, they crush it, they sort it, they mix it into balls with clay. That's what they put in the blast furnace down at Dofasco. That stuff is about 65% iron content. So you just can't use any old iron ore. You need ore that's got a certain percentage of iron in it for this to be successful with this old technology. We found that out by using bad ore and not getting anything. Okay? It turns out the amount of air you deliver to the furnace has got a sweet spot, and this is worth money in the bank, kids. 1.2 to 1.5 liters per minute for every square centimeter of cross-sectional area at rear level. And you can thank Lee Sauter for that, because he's the one that wrote the paper that announced that. And we normally process about 20 kilograms of ore. We use about 50 kilos of charcoal, and we hope to make a bloom in the 3 to 5 kilo range. We don't make them bigger than that, because if you can make one this big, you can make one as big as what's on the table. It just takes more time. If we get a small one, it proves that our system is working. And that's small enough I can forge it up afterwards. Tim? Oh, I'm not paying attention to the time here, sir, so you can yell at me when I'm going too long. Starting in 2007, we started concentrating on specific archaeological problems. And the first one we tackled, due to the influence of a friend and mentor, Kevin Smith, from Brown University, was based on an archaeological dig he did in Iceland at a place called Halls. And this was an industrial level iron processing site from the late Viking Age. A family grouping there made iron over and over and over again for about 2 generations as a way to make money for their family. The problem in Iceland is there's no clay. How do you make something that's fireproof? What they would do is they would cut turfs, kind of sod, but not really the same as sod, different language in Iceland, and you would pile those up in a cone, cut a hole in the center, and use that for the body of your furnace. And we would do a total of 11 experimental smelts in this series, extending. The last one was done in 2024. If someone in the Canadian government wants me to give me a grant to send me to Iceland, because that would be the next step in the experiment, I can't afford it. And there have been formal papers published on this process of experimentation, and there's a report over there. It was one of the books I wrote last year. Whoop. So there's no iron ore in this part of Canada, or in Ontario. And yeah, you could drive up to Minden or Gravenhurst and you probably can find it. Kelly and I went up to Old Woman Bay, north of Sudbury. And yeah, on the nature walk, we found a spot I could have probably gathered enough for a smell. Provincial Park, I can't do it. But finding it in the bush is a little bit tricky. You got to get just the right spot. So what we did is we made up an artificial bog ore. And what we call, it's dark dirt. Dark is my medieval group that I work with. And it's made of Fe2O3 red iron oxide powder that's used to make paints, or to mix with concrete to make red colored flooring. And you can buy that in big sacks. It's used for pottery too, for glazes. 2008, again that same year, something else that happened is I got invited, the only Canadian that went to an iron smelting symposium in Helsingborg, Denmark. There were people there from the Scandinavian countries, from Belgium, and from the UK. I made a lot of good friends there. And again, we smelted every day for a week. The Canadian taxpayer, I got a Canada Council grant to fly over there for this. Thank you very much. Starting in 2009, a lot of these series were overlapping each other. Starting in 2009, we got really, really serious about trying to learn the technologies and the inclinations of what was happening in Vinland at Lanza Meadows 1,000 years ago. That particular series would total 9 smelts. The last one we did was in 2022. It would include 2 experimental firings on the site at Lanza Meadows, about 200 meters from where it had been done 1,000 years ago. And that previous shot was the archaeological drawing of what they recovered. That's the photograph of what we did after the next day. They're virtually identical, which means we've got to be close. We got the same remains. 2014, I got approached about doing a project in Scotland at the Scottish Sculpture Workshop. It was based on Pictish, after the Romans, but before the Viking Age in Scotland, eastern Scotland, based on two archaeological sites, a place called Rhynie and Aberdeenshire, where they had this rather mythic carved stone that's about human size, the original, with this axe over his shoulder. And their intent was to take natural material from Rhynie, smelt it using the 1500-year-old technology, and make a replica of that axe. And we got real lucky because there was an archaeological site, Kudlethal, up near Inverness, like 100 miles away, which is as close as you ever get when you're trying to do archaeology. We did a total of 9 iron smelts related to that project. We made a number of replica Anglo-Saxon and Pictish axes. We used a number of local ores to see whether or not any of them were good. Turns out no. And then the end product of this is I made a replica of the Rhynie Man axe out of iron that we made in the process using the old technology, and then we threw it into a peat bog. Now, it is actually stamped with the 2023 date, so it won't confuse an archaeologist in 500 years. And that's Eden Jolly, who's the fellow that I work with on that project. And I let Eden, who had a better arm than me, do the tossing up in the Isle of Skye. The project we're involved in now, the series we're involved in right now, is exploring the problem of Norse air supply. Remember I said that the more air you put, the hotter the furnace gets. But there's a limit how much air you can put in when a person is pumping the bellows. And one of our problems with the Viking Age is we have two illustrations of Viking Age bellows. They're both blacksmiths. And it turns out that piece of equipment, which I've recreated based on this illustration, is too small to make enough air. It won't fire a furnace. So we would actually do a total of 15 smelts using Viking Age style equipment. We built a giant bellows that makes enough air, but a human being can hardly power it. And the last time we used that, it was about 38 degrees Celsius out, and the boys would not they've stopped me. They wouldn't let me pump anymore because it's actually brutal. This is the mid-size unit. That blacksmithing bellows makes 120 liters per minute, 1 second to pump. This puts out about 500. And that piece of equipment will successfully make iron using Viking Age furnaces. Does it look like what we have from history? Leather and wood, right? After 1,000 years, we do not have one physical sample of the tools. We don't know. That's all guesswork. And eventually, you know, even that piece of equipment, I like to have 3 people, better 4, that do nothing but run the bellows all day, 8 hours, 1 stroke per second. We worked out this cute little mechanical thing that has a sliding gate that moves back and forth. And by changing the motor speed, we can change how fast it pumps. And we hook that up to an electric blower. Not quite the same, but it's close. So, what does this all add up to after 25 years? I've done 101 Bloomery iron smelts. We've utilized 2,560 kilograms of ore, 34 different ores or variations on types of ore over all those tests. We've consumed 620 kilograms of charcoal, which is a lot of bloody charcoal. That's why there's no trees left in places like Scotland, by the way. They cut them all down for the iron smelting industry. We've smelted altogether 590 hours in total. We've made 85 blooms, which isn't bad for 101 smelts, which total almost 500 kilos of blooms. Our average yield, our return, which is kind of important when you think about it, is just over 20%. So we're using all these raw materials. We're not getting much back. That's how it was in the Viking Age. Okay, so one more thing I want to say related to that. Remember I was saying at the beginning that your metal load is almost 400 kilos per year of modern steel. On the table is what they call a currency bar. And it's a little bit bigger than your thumb. It's more or less the length of your forearm. That was the standard way bars were made by the iron smelter to sell to the blacksmith during the Viking Age. It weighs about 2 kilos. That's your iron for your life. That's enough to give you an axe and a knife and your share of the cooking pot. And that's it. Think of how that compares to how much material we have in our modern world and how much stuff we're throwing away. So, because I did all this stuff and I'm an arrogant bastard, I've been trying to publish it. As a non-academic, I don't have really good access to the academic publishing system. They really don't like people without a degree submitting stuff. So I started a website. And as you well know, the iron smelting material alone has got about 1,000 images in it. And there's documentation for every one of the iron smelts. The blog at this point is about 1,200 individual postings. But anybody can do a website who knows if it's true, right? I have, in fact, been presenting at conferences. So up to date, I've done 13 academic conference presentations. I've got 9 either book chapters or formally published articles, mainly in a journal called XArch. It's a journal of experimental archaeology out of Europe. Yeah, I'm getting a little beat up for this stuff, and starting at the end of 2004, I started doing some writing. And to date, I've done 4 published reports and 3 books, which, thank you very much for coming to the book launch, because this is really kind of the book launch for 20 years before the blast. People get the joke or not? Which is documenting all the work I've done in all these years. And I want to put in a commercial note here at the end. I'm in the process of organizing what will be the first Canadian National Bloomery Iron Symposium. It's going to happen at a place called Sanctuary Armory, which is just outside of Peterborough, Ontario, over the Labor Day weekend. Yeah, you've got to pay to go there. It's $350, with the tax in, to be there. Everybody's going to be grouped into a team. They're going to build a furnace and fire it and go home with a bloom. So thank you very much. So,